All right, 19, 20, and 21. Honestly, these should be gimmes too, simply because you can plug them in your calculator and get the graphs. All right, which is essentially what exactly I want you to do. All right, so here we go. Asymptotes for these suckers, unless it is otherwise stated. Remember, the asymptote is at y equals 0. And that y-intercept is that number out front. So this is a y-intercept of 0, 1/2, or 0.5, however you want to write that. Right? And since it is a positive exponent for your e's, remember, it all depends on whether it's a positive or negative exponent. So this is growth. So I'm going to stick this in my calculator, and I'm going to get some points real quick. Give me a second. All right, I always want to get 0 and 1, and then I'm going to want the next 3 as it gets bigger. Okay, so that's 2, 3, and 4, even if they don't fit on the graph. All right, so 0 is 0.5, 1 is 1, actually 0.01, 2 is 2.03, 3 is 4.08, and 4 is 8.22. So here's the deal. I expect to see several things on this graph. I expect to see points, I expect to see an asymptote, and I expect to see a line that follows those points. Okay, if I'm missing those things, then this goes away really quick. So first things first, my asymptote, right there at y equals 0. Okay, you've got your points, 0.5, which I know is right there in the middle. Okay, 1.1, just 1.01, so it's essentially on the dot. 2, 2.03, that's about right there. 3, 4.08, again, that's essentially at the 4. And 4, 8.22. 4, 5, 6, 7, 8. So that's just above the 8 right there. So I got my asymptote, I got my dots, and now we need our line. And do your best to connect your dots and make it look right. Okay? Remember, if you just come to the artistic, whoa, I'm not going to give you any credit for that. Okay? Don't be that person. Thank you. Number 20, same idea. Is this growth or decay? Well, it's a 1/4 in there, so it's decay. Your asymptote is actually at y equals, you guessed it, -7. Remember, it's at 0, but we moved it down 7. Okay. Last but not least, your y-intercept is actually at -6. Okay. Here is y. That is that number out front. That is your a value. So originally, your y-intercept was at 0, 1. But then we subtracted 7. So -7, it became 0, -6. That's what's happened there. Okay. So since it's a decay, I want again, I want a 0 and 3, a 0 and 1, but I want the 3 below it. So I want -3, -2, -1, 0, and 1. All right. I want the 3 points as it's getting bigger and bigger to infinity. So give me a second. There we go. And I get, at -3, we have 57, way too big. -2, I got 9, probably too big. -1, I got -3. And at 0, I got -6. All right, and as if you keep on looking down at 2, 3, 4, 5, yeah, that's essentially getting to 7 really quick. All right, so here we go. We need asymptote, we need points, and we need a line. So 2, 3, 4, 5, 6. Wow, I gave you just enough room on this. Dun, 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 dun. There's your asymptote. And then plot your points. -3, 57. -2, 9. I don't know if there's 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Ooh, there is 9 of them up there. Again, barely enough. -1, -3. That's down, Robert, not up. 0, -6. And then 1, -6.7. I'm right up there. -6.75. Well, that's 6 3/4. So here we go. We got our line that looks kind of like this. It's actually very steep. And it turns right really quickly. Okay. Again, not artistically perfect, but you got your dots up there. You got your asymptote. You got enough to let me know I know what I'm doing. Okay. That's what I need to know. I need to know, do you know what you're doing, more than anything. All right. Let's try the last one real quick. I'm going to pause and move over there. All right. For the logarithm, remember logarithms are just like exponentials, except they're turned on their sides. They are inverses. So your asymptote for a logarithm is at x equals 0. All right. Exponentials there at y equals 0. But remember, you switch x and y. So that's exponentials. This is logarithms. Okay? So your asymptote is at x equals 0, except for when you have a horizontal transformation. So this asymptote is at x equals negative 3. Because remember, everything in the parentheses is backwards. Yes, everything in the parentheses is backwards. And your y-intercept, we'll figure that out when we get to it. And growth or decay, well, we're going to look at it. This one is actually a growth function, I'm pretty sure. Yeah, it's a growth function. Because it's positive, really. The way it becomes a decay function is if you flip it. You put a negative out front. But honestly, you can look at a graph and realize, oh, well, it's slowly going up. And that's fine. It's slowly going up like this. That's a growth function. Otherwise, it's going down like that. That's a decay function. Right? So here you go. Your y-intercept. Let's graph this real quick. Get some points. Now, one thing I will note, okay? Since there is no number right here, no base, that means it's an understood 10. That's a log base 10. Which, if you recall, your calculator is log base 10. So you don't have to do the change of base, which is really nice. You can just type log base 4 log x plus 3, close parentheses, and go to your table. And you will notice at negative 3, there's a big fat error. So here's what I want you to do. I'm going to take negative 2, grab the 0. I want to know when x is 0, so that's 1.991. And then get me we want a total of 5 points, so get 3 more points that fit. So we got, let's do 3. 3 is 3.11. 5 is 3.61. And let's do 8. Oh, 7. There's one that's even. 7 is at 4. Go figure. Alright, so those are what we'll take. So again, start with your asymptote. It's at y is negative 3. So I'm going to put my asymptote right there. Okay. Plot your points. I got negative 2, 0. I got 0, 1.9, which is just practically 2. I got 3, 3.11, so that's just above the 3. 5, 3.61, 3, 4, 5, 3 points, so it's just above half. And 7, 4. 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4. So it's like that. Alright, so this equation, I'm going to do like this. It goes like that. Okay. Again, we're not looking for artistic perfection, but I do want to see points plotted. Give me 5 of them. I do want to see the horizontal. I do want to see the asymptote, and you got to connect the dots as best you can. Cool. And it's got to go in the right direction, I should say. It should look. I mean, if you're at a loss, by all means, hit the graph button and think, oh, well, that's generally what it looks like. So get everything else there, and you know how to follow your pattern. Okay. Just don't go, whoa, and expect me to give you credit for it. All right. Well, good luck to you. Come grab me if you have any questions, and we're done.